Yeah, so thank you for attending this talk called Getting Acquainted with Apache Derby, which will cover the bare basics about the database management system called Apache Derby. I'll start by introducing the Apache Software Foundation and myself, and then I'll move on to Derby, telling a bit about its history and the community around it. And then I'll move over to the product overview, followed by a few words about the new features in the latest version, and I'll take questions if we still have time. Yeah, okay. So how do I fix that easily?
Which resolution did you choose? Is that XGA?
It says here.
No, that's even worse.
Well,
You want?
it depends.
Well, yeah, I guess go back to the slides and do a full screen on the slides and see what it does. But
After changing the resolution.
yeah,
Changing it again.
I think
It
it's
uses
old now.
XGA, so.
No,
Restart OpenOffice. It sometimes doesn't realize that the resolution has changed. At least that's what happened for me. No sweat, we have to bring afterwards.
Yes,
Looks better?
I think so.
Do you try the Yes. There we go.
Yes, so for those of you that doesn't know the Apache Software Foundation, since we already lost some time, I'll skip some of this and just say that it's a community of developers and users for more than 100 different projects, and they're all distributed under the Apache license, which is very liberal.
Is the Apache license a prerequisite for becoming a project under the Apache?
I believe so. Although I'm not sure. So about me, my name is Kristian Wagaan. I'm a software engineer based in Norway. I'm employed by Sun Microsystems. I've been working on Apache Derby for 4 years. I carry out my daily work in the Apache community. And although I get to do lots of different things being part of this community, my recent areas of focus has been in-memory database, backend, performance, and large objects. And I forgot to mention that I'm a committer and I'm also a member of the PMC, which is the Program Management Committee. And there's such a committee overseeing every project in Apache. So, Apache Derby. It's a well-featured relational database, written 100% in Java. Since it is purely Java, it runs everywhere where you can run a JVM. From fancy cell phones using Java ME CDC 1.1 and from Java 1.4 and up. So this can run on your phone, on the desktop system, or even on a mainframe. It has a small footprint, around 2.5 megabytes. If you compress it, you get it down to 600-700K. And since this is Apache, you can actually distribute the single jar file needed for your application with your application itself. So you just ship it out, it's there, you load the driver, and you're ready to go. And it is intended to be easy to use. We aim for a high level of standards compliance, and the two most important standards are the SQL standard, of course, ANSI SQL, and the JDBC specification. Derby has a transactional multi-user relational engine, and on this format is platform independent, so you can copy it from a Mac to a Solaris machine, to Windows or to Linux as you wish. It was originally written to be an embeddable database system, and two important goals for such a system is that it is invisible to the end user, and also that it requires practically zero maintenance. Only with your application, use it, and then it's just there. So this is a little bit about history. I'll just say that IBM donated this in 2004. Some joined the community in 2005. We graduated later the same year from the Apache incubator, where every new project has to prove that it has an active and lively enough community to support the product. And the first official release was 10.1. Released in August 2005, and currently we are at 10.5 from April this year. We are using the Apache infrastructure, for instance the source repository, mail servers, websites and so on. And practically all our communication goes through the mailing lists, and these are archived for later reference, so you can go back in time and see what we discussed and decided and so on. There is some communication taking part on an IRC channel, and if there are important discussions, minutes are posted to the mailing list, so they are archived as well. And today we have groups of contributors in the community. We have the larger company involvements. Those I'm aware of are Sun Microsystems and IBM. And then we have a number of independent contributors working for smaller companies or out of their own interest. The last year we have also had the pleasure of having Google Summer of Code students. They have carried out several projects in the community. And the community, which also consists of the users themselves, receive feedback through the users mailing list, the issue tracker, which is Jira, and we also get some company internal feedback, some of which is taking place on the public user list. Being part of Apache, we have a well-defined release process, and there are two types of releases. There's a feature release and there are maintenance releases. They both start out by a committer volunteering to be the release manager, and the manager then schedules key points. It is the branch creation, which involves a slight period of code freeze, followed by a beta build and the release candidates. And then the draft of the release notes are circulated for commenting. And during this time, after the first release candidate has been cut, there's a period of increased testing. And this is followed up by community voting at the end of the period. If the vote passes, the release is published. And maintenance releases are slightly easier to produce because you don't have to cut a branch, and there are also less code changes. So you have more confidence that the release is sound. This is just a list of tests that the community run and publish. We have a tinderbox test for every code change. We have daily tests being run on multiple platforms and JVMs. We have performance regression tests, large data volume tests. I think we test with tables consisting of 300 million rows and databases around 200 gigabytes at the moment. And we also have a long-running test which runs up for up to 3 months. But this is often aborted if you have a new release coming out and we just restart it again. We also started using Hudson for continuous integration. And currently the community, I believe we have just released 10.5.3, where it will be released any day now. And we have also started work on 10.6, the next feature release. There are 2 active distributions of Apache Derby. The first one is Apache Derby by the Apache Software Foundation, and then Sun Microsystems has JavaDB. These are essentially the same, except that JavaDB has rebranded documentation and some installers. And Sun did this so it could sell support for JavaDB or Apache Derby, and also get some more flexibility regarding bug fixes for customers. And Cloudscape was a distribution maintained by IBM, but they have stopped distributing Cloudscape, but they are still involved in the Apache community. So, the product overview, what do you get? I'll start by explaining how you can run Derby, 3 different modes. The first one is the purely embedded mode. Basically, you just load the driver in your application and obtain a connection, and then the database is up and running and you can start using it. Again, this is very simple and you can use it practically everywhere. Then we have the traditional client-server architecture. Nothing to tell there really, except that the network server bundled with Apache Derby uses the embedded driver internally. And you can, of course, also use your own network server framework, for instance, an application server, instead of using the bundled network server that comes with Derby. And then the last one, which is a combination of the two. There you have your main application connected to the database through the embedded driver. This gives you better performance because you don't get the network layer overhead. You just make Java method calls into the database. And then you can additionally start a network server and have secondary client connect to the database or the network. Or you can connect yourself to do monitoring and administration. And this is also useful in an application server. You can use Derby as a front-end cache to your back-end database. You just put it up in the application server and you can monitor it and administer it using any JDBC client, really. As I said earlier, multi-user, multi-connection, and multi-threaded relational engine. We do support the ACID properties, transactions for atomicity. We have foreign keys and check constraints to help maintain consistency. We support all 4 isolation levels, and we have crash recovery by using write-ahead logging. The only thing to be aware of there is that you have to turn off your disk caches for this to work properly. Otherwise, you may lose some committed transactions if they haven't been flushed to disk and the power goes. We're using row-level locking. We also have table-level locking, which are useful in read-only databases or single-user applications. Uses less memory. And since locking can cause conflicts, we have deadlock detection and lock timeouts. We support online and offline backup, and of course restore. There is also a roll forward recovery mode where you save all the logs so you can roll forward until you hit corruption. Further, we support encryption both on wire and encryption of the database itself. This is useful when we have databases in the wild, since it is so easy to distribute Derby. Sometimes you're not sure if your clients can protect the data themselves, then you can at least encrypt it for them.
Which encryption algorithms do you support?
We support any block encryption algorithm, but not streaming algorithms. Mm-hmm. Basically anything that you can support using Java. Okay. Stored procedures and triggers supported again with Java. So you can basically write any Java code and embed it in your database, or you can do it the other way around, embed the database in your Java code. Both ways. And one use case here is to integrate, for instance, memcached or ehcache. That's a few lines of code when you have the Java bindings. Yes, when it comes to SQL, we support the major features. I'll just skip over to the cost-based optimizer, which Derby is using. And there it is important to note that Derby is compiling the queries into Java bytecode. The good thing about this is that the Java hotspot optimizer can optimize your queries as well. The bad thing is that it's rather expensive. So it is very important to use prepared statements and also to reuse them. Further, we support read-only databases in a jar or a zip, which is perfect if you want to distribute your company catalog. Create a read-only database, put it on a memory stick, and hand it out, including the database itself. We also support access through read-only databases that are accessible on the Java class path. We have a client-side JDBC statement cache. This is useful in application servers, for instance, when you have connection pools. In that case, your clients don't have to re-prepare every statement each time it gets a new connection from the pool. And Derby can also be used as part of distributed transactions. So we have XA support. And before I move on to new features, I'd like to spend a few slides on Derby table functions. They are a neat feature to have. Basically, you can access any external resource using SQL. This can be non-relational data, for instance, plain text files or XML. You can have legacy data sources, or you can even access other databases to create tier-of subsets. You can import data, migrate data, or even do distributed joins. The way you do this is that you create an implementation of Java SQL result set that knows how to feed your external data source. This is then accessed through a public static void Java method. Next, you define a function in Derby and you invoke this function as part of your SQL by specifying it in the from clause. And there you can pass arguments to the table function. And there are several ways to use this with SQL. The simplest case is just to do a select from the table function. This is useful for development, testing, and in cases where the table function is cheap to invoke. Next, you can import the data into Derby by doing an insert into select from, and then you do more extensive processing of the data. And lastly, you can do a create table from the VTI shape to create a table required to hold the data for the import. So, then I'll just move on to new features. We added generated columns. These are columns automatically generated and updated based on the content of other columns in your table. Of course, you could already do this with SQL expressions or even calculating the values in the Java application, but the generated columns can be indexed, which again allows for faster searching and ordering on expressions. The downside being that you need some more space. So here's a really simple example of a table holding circles, radius int, and then you calculate the area. And as a second example, I show how you can add an external function to Derby. Create function myPow taking two doubles and returning a double. It has to be defined to be deterministic to be allowed in a generated column. And this function will then invoke java.lang.math.pow. And using this in the table definition, we then calculate area as I times myPow radius, 2. SQL roles were added in 10.5. They are modeled after the SQL 2003 specification. They allow you to bundle a set of individual privileges as roles, which you can then assign to users, and roles can inherit from other roles. Roles by themselves don't give you better security, but they simplify administration and they make the whole process of granting and revoking privileges less error prone. In Derby there is no default role when you connect, so you have to use set role. And you must also enable the SQL authorization mode. By default, Derby doesn't do authorization, so that is why you have to enable it. And there's a current limitation, which is that only the database owner can manage roles at the moment, that is, create and delete roles. We finally added the in-memory database backend. Of course, it stores data in memory only. and it is useful for transient or temporary data. When you shut down the JVM, the data goes away. And use cases for that are development and testing, ad hoc queries, or maybe even database initialization. Because since you keep the data in memory only, you don't have to go to disk on your commits, so you can boot and create an in-memory database, populate the database, and then take a backup to disk. And the next time you use the database, you can then use the normal disk-based engine. You can also do it the other way around, so that you boot a database from a disk image into main memory, and then you can experiment with it or do changes, and when you then shut down the JVM, the disk image is left untouched. Yes?
Your complete databases in memory then, and not only one table or so.
The complete database, there is one exception, and that is the derby.log file, but that is just the error log, and you can configure it to go away as well. So you leave no traces on disk. And this isn't feature complete, so we're looking for feedback from the community. What other features should be added? For instance, automatic persistence on JVM shutdown. That is one feature that has been mentioned. And the in-memory database backend makes the Derby table functions even more interesting, because then you can process data kind of more or less on the fly, and then just throw it away when you have the result you need. As I said, Derby uses a cost-based optimizer, and non-unique indexes have cardinality statistics, and when these are severely outdated, the optimizer makes stupid decisions. So it is important to update these statistics, and this can now be done in 3 different ways. You can call a stored procedure, you can compress your tables, or you can simply recreate the indexes. We're also doing work on making the whole process automatic, as it really should be. So we hope to get this done in 10.6. Something users have requested for a really long time. This is the limit or top functionality. This has now made its way into the SQL standard. A bit more verbose than you could have hoped for, but that's how it is. It has been specified. Yeah, as I said, it's the limit or top functionality. Fetch me the 5 rows from this query.
Consider that MySQL has made an SQL standard. Wow.
Well,
This is
how it's been standardized, but limit was first implemented in MySQL.
okay.
does it does first and next, but does it do like an offset? Like, do you have to do a first
Offset?
to do a next?
No, I don't think so. You can do your select and then say offset 10, fetch next 10 rows.
Oh, okay, that's what we're
Then
going
you
to
get rows 11,
Right.
20. It is not feature complete either. In 10.6 we want to add, or we want to allow offset fetch in subqueries, and we also need dynamic parameters for offset fetch, especially since compiling queries are rather expensive in Derby. I think replication was covered in the previous talk, so I'll just say that Derby supports basic master-slave replication as well. It is asymmetric and asynchronous, and we have manual failover and takeback. And new in 10.5 is that we added support for replicating encrypted databases. And this replication is log-based. Note that you can also replicate an embedded database, which can be neat, so you don't have to start a network server to use replication. Finally, large object improvements. I would say large objects are pretty well supported in Derby. They are read-write, of course. Previously, we have done work on avoiding materialization, and in 10.3 we added a locator-based implementation. That is, you do as much work as possible on the server, so you don't have to transfer the whole large object to the client before you can start working with it. And in this release, we improved the streaming, we improved the positioning, which is a bit challenging in Derby because we're using UTF-8 encoding. So each character can be represented by 1, 2, or 3 bytes. So we're not able to do direct addressing. So we rely on decoding and caching of positions. And then we need some additional work on avoiding doing unnecessary work. We had some bad algorithms. And finally, we made sure that resources are freed on the server as soon as possible. So where to get Derby or JavaDB? You can go to Apache and download it from there. You can also go to the Sun Microsystems website and get it there. It is bundled in the Sun JDK for Java SE6. If you look under the DB subdirectory for JDK installation. Ubuntu has a package for it, and so does OpenSQLCamp as well. So that was all I had. Thank you for your attention. And then I can take questions if there are any. Yes?
Can you say something about performance compared with other databases?
Well, as you know, you can basically get the performance you want by tweaking your load. And that's how it is with Derby as well. We have done performance tests, and in many cases we do better when your database doesn't fit into the database cache.
Mm-hmm.
And we have benchmarks showing that in some cases we are faster than MySQL, in other cases we are slower, and in other cases again Postgres beats us both. So it is hard to say, but I would say performance is acceptable and good in many cases. One thing to note that since we are so compact, there are some really even more compact systems out there, but they don't have as many features, and some of them have even been single-threaded, and of course they beat us when it comes to really simple benchmarks.
What is the most common use case for Derby? Is it embedded in applications or standalone as a database server?
I would say the embedded use case is more common because it is so simple to distribute and to use. And we've also seen uses of it in application servers where you use it as a front-end cache for your back-end database.
The second question is, are the databases and tables contained in a single file on disk, or is it spread across multiple files?
No,
how does the layout of disk look like?
You have one directory containing a database, and within that directory you have a log directory and a data directory. And for each conglomerate, that is index or table, you have a separate file.
Okay. So it's not like SQLDB where you have just a single file that contains it?
No, we have multiple files contained within a single directory. Unless you want to save the log on a separate data device for improved performance. That is supported.
Okay, no questions?
Okay, thank you for your attention. If you have more questions, just find me somewhere during the conference.
You'll be around tomorrow as well?
Yeah, I'll be here tomorrow as well.
Well, and we have the panel discussion.
Discussion, yeah.
Okay.
If there